Hallo, it's dumplet here. Here's an item on geometry. Take a look at the figure on the left. P is the midpoint of minor arc CD. AM is equal to MB, so M is the midpoint of AB. CD is equal to 1, and AB is equal to the square root of 2022. Find the length of AC. Now this item came from DAM 2022, an examination that dumplet has hosted. The link to the PDF file will be in the description. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. So just by taking a look at the figure, we do have circles involved, arcs involved, and here we have actually two line segments, CB and AB. They are secants in this case. So let us start by using the power of a point. So one of the classic things we use whenever we're given with circles and kind of segments. So let's try to do that here. So by the power of a point, let me just make dB over here. Let me just assign dB to be just x, and by the power of a point, we should have the following. So x times x plus 1. So this should be equal to the square root of 2022 divided by 2 times the entire square root of 2022. And all right, the right-hand side, so just squaring, just 2 square root of 2022. So we could just have 2022 divided by 2, and then simplifying, we're going to get 1011. Now, technically, I could solve for x here, since x times x plus 1 is 1011, but x is going to be pretty ugly, so I'm just going to leave it as it is. So our first observation is that x times x plus 1 is equal to 1011. Now, next, we do have a cyclic quadrilateral here, AMDC. And since we have P to be the midpoint of the arc, maybe there are some angle conditions that we could use. And in fact, we should be able to find a pair of similar triangles that we can work with. All right. Now, again, this might not be obvious to everybody that we're going to find similar triangles, but these are common techniques in solving these items in geometry. So expect something like that to happen whenever you're solving, because, well, we never really know what to expect when we solve a problem. So anyways, I'm going to connect CM and DM over here. And let's make use of the fact that P is the midpoint of minor arc CD. So in effect, I should have arc CP. So I should have arc CP that's going to be equal to arc PD, right? Now, angle CMP would have to be equal to angle PMD. So angle CMP would have to be equal to angle PMD because they intercept the same arc, two arcs with the same measure, right? So those two red angles should be the same, and well, we have PM perpendicular to AB as seen in the right angle indicated there. We should have angle AMC over here and angle DMB over here to be the same because we're just taking the complement of both red angles technically. All right. Now we could try to use the cyclic quadrilateral condition. Angle AMDC is cyclic based from the figure, so I'm gonna call this angle CAM. So angle CAM and this angle CDM, they should be supplementary because, well, they're opposite angles in a cyclic quadrilateral. And, well, angle MDB over here, it forms a linear pair with this yellow angle over here. So angle MDB, this angle over here, should also be blue. So this angle is the same as these two blue angles are the same. That's what I meant. So we could see here that triangles CAM and DMB, they are similar, right? Now let me just fix the correspondence here. Let's just fix the proportions. So to write this in a little bit more formally, I'm gonna write as triangle ACM being similar to triangle, well, let's try to see here. The blue angle is at vertex A, so I should put vertex D here, so D, and then C. Now let me just put a black angle here for angle ACM, which is going to correspond to angle DBM. Well, again, we're concluding that these two this pair of triangles is going to be similar because of the angle-angle theorem. All right. Now, so C has a black angle. It's going to correspond to B in the other triangle, and then the last is going to be M. All right. So writing the correspondence a little bit more properly. Okay, so we do have similar triangles that we could use. Now, let me just write down some possible relationships we could use. Now, since we're asked about AC, it's very, I guess, obvious that we're going to write in terms of AC as well. So let me just write AC is to AM, which I know it's square root of 2022 divided by 2. So that's AC is to AM. So I should form dB, which I know the value of. It's x. That's what we assigned. So dB was x. So AC over the square root of 2022 divided by 2. That should be equal to x divided by. So dB divided by dm. Now dm, I don't know what it is. I don't know what it is. So I just write dm for now. So let's write this as dm. All right, and let's try to form another. So I should be able to form another ratio. So let's just say we have AC is to CM. Now I have no idea what these two things are, so I'll just write it like this. That's going to be equal to, on the corresponding triangle, it should be dB, which I know is x, so dB divided by BM. Now BM is half of AB, so BM here is the square root of 2022 divided by 2, right? So these two, well, they're not the prettiest equations, but we do have two similarities, two proportions that came from the similar triangles. And let's try to see what we can do here. Now, take a look here. AC, so AC, DM, and CM, they are lengths within quadrilateral AMDC, a cyclic one. So AC and DM, they're just sides, and then CM is a diagonal actually. So we might try to form a relationship between these things. And well, since we have a cyclic quadrilateral, one of the more well-known theorems in cyclic quadrilaterals is the Ptolemy's theorem. All right. So these two similarities I've written down here. So just for reference. And then this is the one for the power of a point that we got from a while ago. Now, let's talk about the Ptolemy's theorem. The sum of the product of the opposite sides is equal to the product of the diagonals. Now, writing it in terms of an equation here, AC times DM plus AM times CD, that should be equal to product of the diagonals, CM times AD. Now, before I move on further here, let me just explain a key concept here, because I'm going to say that AD, so I'm going to connect AD here, AD is actually the same length as AC. Now let's try to prove why. Because, well, P is the midpoint of arc CD, okay? And we do have a perpendicular a right angle here at M. So, well, obviously this is going to mean that this is going to be right as well. And we do have angle AMP to be right. Now, so this angle intercepts arc AP over here. Well, by the Taylor's theorem, AP must be a diameter of a circle, right? Because AMP over here, there's a right angle here, so AP over here must be a diameter. Now, since it's a diameter and P is the midpoint of arc CD, that's going to mean that AP over here must be perpendicular to CD. So we could just focus on this kind of height of triangle AZ. This part serves as the height of triangle ACD. And because we do have like kind of a symmetry here, this point over here, let's just call this point Q. Point Q will be the midpoint of segment CD, right? Because P is in the midpoint. P is the midpoint of arc CD. Q must be the midpoint of segment CD. We can conclude from this that triangle ACD is isosceles, right? So triangle ACD must be isosceles. And with this, well, AC would have to be equal to AD, right? Because we have an isosceles triangle. So the AD here, I could write it as AC. Now I could simplify the other things as well, because, well, AC times DM, yeah, we don't know what those things are, but AM, we know that's square root of 2022 divided by 2, and CD is given to be 1. And then CM times the AD, as I mentioned a while ago, that has the same length as AC. So at least this is a little bit, I'm going to say more simple, okay? Now we do have a lot of equations. We have 3 already from here, and we have the 4th one. Let's try to put everything together, and hopefully we could kind of solve for AC. So, because technically speaking, we do have 1 unknown, 2 unknown, 3, 4. So 4 unknowns, and we do have 4 equations. So I think that should be enough for us to get the value of AC. Okay, now I just kind of simplified this one, right? So there we go. There we have it. Now let's try to write everything in terms of hopefully just AC as much as possible. So I know that I could solve for CM here. I would get that CM, which is just MC so CM, that's going to be equal to AC times square root of 2022 divided by 2 times 1 over x. Okay, there we go. And, oh, whoops, sorry. So CM should be equal to, oh yeah, so there we go, times 1 over x. And then dm over here is equal to x. Oh, you know what? I could write this as dm times AC. So AC times dm, that's just equal to the square root of 2022 divided by 2 times x. All right, now the reason why I'm writing it like this is because, well, I just want to eliminate other variables as much as possible. So taking a look at here, AC times dm, well, that's just that. I could replace it by 2022, the square root of 2022 over 2 times x, apparently. And then we're going to add, well, just adding this one, square root of 2022 divided by 2 equals. And then we do have CM times AC. Now we do have an expression for CM, not the prettiest thing in the world, but we could work with that. So AC times the square root of 2022 divided by 2 times 1 over x, and then times another AC. Now, I see that we have a lot of square root of 2022 divided by 2's. We could cancel that out nicely. So we're just going to have x plus 1 is equal to, let me put the 1 over x in the front. So the 1 over x, and then we do have AC squared over here, right? Now, multiplying both sides by x, AC squared is equal to x times x plus 1. And that's pretty interesting because the last condition is used now. X times x plus 1 is 1011. So we do have that AC squared is equal to 1011. Pretty interesting. Everything cancels out nicely. We do have AC squared. Last step is just to take the square root of that. So AC squared would be the square root of 1011. And this is indeed the final answer. Now, I think the more interesting fact about this question is that, well, I did make, in the given, I did set CD to be equal to 1. But in fact, you could try to answer the question, try to make CD general, like let's just say A. And regardless of what CD is, you can actually prove that AC, no matter what, it's going to be the square root of 1011, right? Now, this part is for you guys to find out, but hopefully you guys like the question, all right? So hopefully you guys learned something new from this video, and I'll see you in the next one. Bye-bye!